Hello everyone. In my previous concept, I just gave introduction to projectile fired at an angle theta with the horizontal. So the noticeable thing at here, the vertical component of projectile during the motion is changes. It's due to because of the acceleration due to gravity. So when we launch a projectile with initial velocity, so in two-dimensional plane, so the velocity is resolved into corresponding components, the horizontal component and vertical component. And during the motion, the vertical component of the projectile, the vertical component of velocity during the projectile path is changes. It's due to because of acceleration due to gravity. That's the reason the projectile takes the parabolic path. But throughout the motion, the horizontal component of velocity, it remains constant. It means on the horizontal component of velocity, the acceleration due to gravity do not affect. So the great thing at here, the very important point, at the maximum height of the projectile, the vertical component of velocity equal to 0. So let us try to derive some mathematical part in this projectile motion. Suppose this is a two-dimensional plane, so this is x-axis and this is y-axis. So at origin O, so I am going to launch a ball. If we take a small ball, a small sphere of ball mass, it's having mass. So let it take its mass m equal to 1 kg. Mass m equal to 1 kg. It is launching with the initial velocity. Initial velocity as u. So since it's two dimension, the initial velocity is resolved into two components. So this is the horizontal component. You can take that as u cos theta, that is u suffix x, which I write it here, u cos theta, u suffix x, and vertical component equal to u sin theta, and the vertical component is along y-axis. So this is u suffix y equal to u sin theta. Where is the resultant velocity? The resultant velocity of these two is, this is the one. So this is the resultant velocity u. Suppose this ball take a parabolic path. So in the projectile motion, let it be its parabolic path. Now let me take a point P at here. A point P. I would like to find some things. So this point P is at x comma y. The perpendicular distances, it can be measured. So this is the corresponding the x point location and the corresponding y point location, if you can figure it out. And same thing, the corresponding y point, this is exactly on the line. So this is the x and this gives y. The distance, it can locate where is in the two-dimensional plane. Now after launching, here I need to take a very important factor, that is the projectile is launched at an angle theta. So the theta must be with the initial angle theta. Now at point P, so the projectile velocity changes. Now if it is having a velocity, I'll take this. If it is having a velocity v, So at here, so this is the velocity, this is the resultant velocity. Now this velocity we take as final velocity v. Now this velocity at this point is resolved into two components. So this is a horizontal component and the vertical component. So this is the vertical component. So that is, you can take exactly on the point. Yeah, this is the vertical component. So if I label this vertical component as v suffix y, the vertical component v suffix y and the horizontal component v suffix x. So now at here the projectile angle is changes. Now here that angle, no need to mention it here, but you should remember that the projectile angle is changes. Suppose this is the maximum height of the projectile. So if you can measure throughout the motion from the x-axis, what is the maximum height? So at a this point, if you can take that, the maximum height. So this I mentioned that h suffix max. And if I take one more point at here, so if this is the resultant vector direction, now that velocity also dissolves into two components. One is the horizontal component and another one is vertical components in this downward direction. So this is, I can write that v suffix x and this is v suffix y. And when it comes to at the end, so that is very important for us at the end. So the velocity also having the same component, this is the resultant velocity. Now at the end the things will become same as initial. Now the initial velocity becomes u cos theta. So this is initial velocity u suffix x equal to, the final velocity component v suffix x at here equal to u cos theta, and the vertical component at here v suffix y equal to u sin theta. And here the angle making with the horizontal, again here angle goes to theta itself. So now the starting conditions and the ending conditions, they both are the same. Now here I need to define one more important thing is that is nothing but horizontal range. So the maximum horizontal distance between the initial to final point is known as horizontal range R. So let us dive into the derivation. Before that, I am going to write the two important things at here. Please fix it in back of your head, these 2 points. The horizontal range, that is u cos theta, which remains constant, throughout the motion. The horizontal range u cos theta remains constant throughout the motion. Now here the game change factor, who is that? The vertical component. The vertical component that equal to u sin theta. The vertical component u sin theta, which changes with time, because of due to gravity, under effect of gravity. So these 2 points are the very important. Yet only the vertical component of velocity is changing. Who is the cause? The cause is none other than that acceleration due to gravity. Now let's try to find one by one. So the first thing we need to figure it out, that equation of trajectory. Equation of trajectory of projectile. So we consider at a point P, x, y. So that is after a time t. So this point P in the location where I considered in the projectile motion. So that point P is considered after launching a time t. Now there we need to find the horizontal distance covered by the body in time t. The horizontal distance covered by the body in time t. It's a horizontal distance. So horizontal distance means nothing but the x at here. So distance formula, velocity equal to distance upon time, and the distance equal to velocity into time. Since it's the horizontal distance, we get that horizontal velocity into time. So horizontal distance here, x equal to horizontal velocity multiply with time. So we know that horizontal velocity is nothing but u cos theta, x equal to u cos theta times t, the time here taken t itself. From this I need the term t, time t equal to x upon u cos theta. I will make use this equation ahead. So time t equal to x upon u cos theta. Likely figured out the vertical distance. So for vertical motion, here the vertical distance is equal to y. You got it? For vertical motion, vertical distance, the vertical distance here equal to y, and vertical velocity equal to u sine theta, and here changing factor acceleration due to gravity. Acceleration due to gravity. This acceleration A equal to negative g, because the body is moving up, acceleration is always at downward direction. Now if you use the second equation of motion, that equal to s equal to ut plus half a t square. Here s is nothing but vertical distance. Yeah, vertical distance or vertical displacement both in this scenario is same. So in the present case, the vertical distance y equal to s. Now I will change this expression by substituting what I am having right now at there. So y equal to u becomes u sine theta times t plus half negative g t square. So we are having t value at here from above, so we can plug in the t value at here. Since t equal to x upon u cos theta, now y equal to u sine theta of t here x upon u cos theta. minus g by 2 times x by u cos theta whole square. So here u gets cancelled and the term going to change converted as y equal to x tan theta, sin upon cos, it gives tan, minus g times, I can multiply that, g times x square upon 2u square cos square theta. Oh, it's a very big mathematical expressions. This much big thing is difficult to remember, so we make it short. That is y equal to, we can write that p times x minus q times x square. So here p equal to tan theta and q equal to g upon 2u square cos square theta. So this is the expression for parabola what we represent in mathematics. So don't get confused with the earlier concept. I say we draw a parabola equation in a projectile from launching at a height h. So this gives that y equal to kx square. But a full projectile, so to this motion, so this we represent that in mathematics y equal to, so kx minus rx square. So this is also a mathematical projectile expression, the general form. So take it, this equation as a projectile equation as granted, since we don't know much about that in mathematics. We will learn in this course of time. So till that you can trust me and I can directly write it here. The y is a quadratic function of x, hence the trajectory of projectile is parabola. Hence the trajectory of a projectile is a parabola. Not only that, we already seen that virtual demonstration. So the path of projectile is giving parabola. So this parabolic mathematical expression goes to y equal to px minus qx square. Now this is the equation of projectile. Now let's try to get the second one. The second term which I need to find, that important time of flight. How you define the time of flight? It is the time taken by the projectile from the instant it is projected till it reaches to the point in the horizontal plane of its projection. It means the time taken from instant it is going to project. Suppose if I am having a timer at here, the clock is on at here soon after launching, and the clock is running till it touch down in the horizontal direction only. Now if the clock is went up to certain seconds, let it be here. Now the time taken by the clock is known as time of flight. According to definition, the time taken by projectile from the instant it is projected till it reaches a point in the horizontal plane of projection. So in this diagram, the horizontal projection reached a point B, means the starting point and ending point. This is the point which I am going to highlight. So you cannot notice that, which I am going to highlight with a different color at here, blue. So in the diagram, this is the point and this is the starting point of the ball which I launched. Now how to find the time of flight? We can use the second equation of motion. Since in the second equation of motion, why it is used? What is the net net horizontal displacement. The projectile is launched at here initially, then again it launched on the same horizontal point. So if you are calculating only the horizontal displacement, this we are calculating only the horizontal displacement. What about the vertical displacement? So the vertical displacement initially at 0 only, and finally also it's 0. So here only horizontal displacement is there, horizontal displacement. But what about the vertical displacement? The vertical displacement in this case goes to 0, because the projectile is launched from origin, again it is landed in the same x-axis only. So that's the reason the vertical displacement covered during the time of flight equal to 0. So please remember this and try to get it this point. In this projectile motion, the net vertical displacement, covered during its time of flight equal to 0. So here I am going to highlight a word that is known as the net vertical displacement. So you know what is the difference between horizontal displacement and vertical displacement? Vertical displacement means in a simple way along the y-axis. Along the y-axis initially the vertical displacement equal to 0, and finally also along the y-axis the vertical displacement equal to 0. So the net vertical displacement along the y-axis equal to 0, because the projectile is launched only in the horizontal displacement. So if you can, I use this in second equation of motion, s equal to ut plus half at square. Here s equal to net vertical displacement. And u equal to u sine theta, vertical velocity. And here little t equal to, I can use a character time of flight, t suffix f. And a, yeah, that we already know, that acceleration due to gravity. Now if I substitute this at here, now s value is 0, equal to u changes as vertical velocity u sine theta of t we are calling time of flight, plus half acceleration negative g minus g times t square. Here t square value equal to t suffix f whole square. T we called as time of flight. So 0 equal to u sine theta t suffix f minus g upon 2 t suffix f whole square. Now if we can interchange these two, we can get it u sine theta t suffix f equal to g upon 2 t suffix f square. We cut this 1. If you can cancel tf with one of the terms. Now the time of flight tf equal to u sine theta upon g by 2, and we can do the reciprocal, so it becomes 2u sine theta upon g. Therefore the time of flight t suffix f equal to 2u sine theta upon g. Now the time of flight is depends on u, initial velocity, and theta. Here the theta is changing factor and inversely proportional to acceleration due to gravity. So this is the expression for time of flight. So in this time of flight, the key point you need to remember, the vertical displacement of the projectile equal to 0. So that we use to find the time of flight. And the next thing I need to figure it out, that is maximum height. How we define maximum height? It is the maximum vertical distance covered by the object during its projectile motion. Suppose this is projectile motion, the maximum height. So this is so called, we call this as A is maximum. So the maximum height, vertical height, keep in mind, the maximum vertical height covered during its projectile motion. Now very important point at here, at maximum height, what is the vertical component of velocity? The vertical component of velocity at maximum height equal to 0. So this is the needed component at here to me. At the highest point, A, the vertical velocity that equal to v sine theta. V sine theta equal to 0. So that we already observed in that simulation. So that is a very key point in the projectile motion. At the maximum height, the vertical component of velocity equal to 0. If it is like that, we can use third equation of motion, that is equal to v square minus u square equal to 2as. Here v equal to final velocity at h, final velocity that equal to v sine theta at point A, and u equal to initial velocity that equal to u sine theta, initial vertical velocity. Initial vertical velocity, and A is negative g, and s equal to maximum height h max. So substitute this in this third equation of motion. So 0 square minus u sine theta whole square equal to 2 times negative g and h max, s equal to height maximum. So I can get it here, negative u square sine square theta equal to negative g h max, and the negative term gets cancelled, therefore h max equal to u square sine square upon 2g. So this is the expression for maximum height. So the maximum height is again the factor of u, initial velocity, and theta, angle of projection. If theta changes, the maximum height also changes. Now let's figure it out another thing which is very important, horizontal range. Horizontal range. The horizontal distance, suppose this is x and y plane, we launch a projectile like this, so it went up to here maximum H max. So this we already figured it out right now. This is H maximum. The important point at here, the vertical velocity v suffix y equal to 0. But when it comes to horizontal range means from the starting to the ending point of the projectile motion, the horizontal distance traveled by the projectile during its time of flight is known as horizontal distance. This horizontal distance we represent with a capital R. It is the horizontal distance covered by the projectile during its time of flight. So that we define as horizontal range. So horizontal range, here by seeing this range is nothing but distance. Horizontal range equal to, it's the horizontal velocity times time of flight. Just like distance formula, distance equal to velocity times time. So horizontal range, here the horizontal range means nothing but distance equal to, it's the horizontal velocity only, not the vertical or together. It's the horizontal velocity times time of flight. So now I got it, horizontal range R equal to horizontal velocity. This is the factor which do not change during the time of projectile motion. Your horizontal velocity equal to u cos theta times time of flight. Time of flight we got it from there. It equal to 2u sin theta upon g. It's equal to 2u sin theta upon g. So let me make it short. I can write this 2u square sin theta cos theta upon g. So we can use here one of the trigonometric identity. I can rewrite that as a trigonometric formula. So u square I can write first. I can rewrite this 2 sin theta cos theta upon g. So we are having a formula in the trigonometry that equal to 2 sin 2 theta equal to 2 sin theta cos theta. This is one of the trig identity. We will use the trig identity here to shrink the formula. Now the formula will become much shorter. So that equal to u square sin 2 theta upon g. So the maximum range the projectile cover during its time of flight equal to u square sin 2 theta upon g. So here the range is directly proportional to initial velocity square and range is directly proportional to theta also. If any of these two factors changes, the horizontal range is changes. So this is all about the derivation which I am going to do, so in the projectile motion, particularly when it launching with an angle of theta with the horizontal, the two important factors at here, during its projectile motion, the horizontal velocity, here it's supposed to horizontal velocity, the horizontal component, the horizontal component u cos theta, which remains constant throughout the motion, and the vertical component u sin theta, that changes with the time It's due to because of gravity. And we derived the projectile equation, which gives a parabola y equal to px minus qx square. And next we derived that time of flight, time taken by the projectile, tf equal to 2u sin theta upon g. And maximum height, the h max equal to u square sin square theta upon 2g. And finally horizontal range, r equal to u square sin 2 theta upon g. So let us see how projectile motion changes if we change initial velocity and angle of projection theta, how this range and time of flight or maximum height, they are going to change. So that we will see in another lecture.